Hello everyone, welcome to my channel. Today I will be working on this nice beautiful looking Nakamichi ZX-9. Its front panel is almost untouched, like over all these years. As you may see, top cover a little bit worn out. I don't know if it was cleaned like that or it was sitting on the sunlight, never. But it's not in the same shape, but it's still nice for these years already. You see, all buttons are covered with these little covers. I mean, like all buttons for azimuth, not azimuth, for calibration. Yeah, you see, those are pretty tough covers. I'm not sure if they've been used or not. Alright, let me see what we have. Door is open, so this deck managed to give to me safely, and tape transport was not broken. That's a good sign. Light works. That's the head condition. I see that right capstan is rolling, but left capstan is not, so belt is gone. Right. Left pinch roller moves, right pinch roller moves. That's a good sign. Now, let's see, fast forward. Okay, it's weak, but it works. Rewind the same. Play back. You see, heads don't coming up. So, what I will be doing, as usual, will remove top cover, front panel, and then pull up tape transport to be able to work on it safely. And then I will assemble transport back, and we will start looking what else good or wrong with this deck. But looks like it was not abused. Yeah, it was, top cover was opened. I see marks on the screws, but let's see how it was serviced before and if I would be able to bring it to life. See you in a moment. And here, guys, I'm in the process of disassembly. I just pull it up, these 4 connectors which connects front panel to this board here, and I can take a look at the belt or remains of the belt. It would be some job to clean it up, but you may see how long ago it was replaced and how it was deteriorated. And I found like the deck has been serviced before, but it was very long time ago, really. Alright, moving on, trying to complete this assembly. I need to remove more connectors to remove this panel from the deck. See you soon. Okay, you've probably already seen this view, but here is the amount of connectors. 2 connectors from the tape counter, and this set of connectors from the control buttons and indicator. And I disconnected the azimuth wire, so it's not moving. It's so hard. Okay, everything is stuck here as well. Alright, moving on. See you soon. And finally, tape transport is off. It took some time to pull it out. It's not easy procedure, but what I learned is that one of the stands has been broken. When I started to unscrew the screw, it was just rotating easily. So that's where we would need to fix it. It's a known issue of this tape transports due to everything holds by these plastic pins and stands. And that's where they're not that good in the transportation, specifically as it happens these days when shipping companies just don't care. Everything is insured, so they just drop the boxes, and that's when it's dropped to the lower part, the weight of the mechanism just pulls the stands apart. All right, Now I will be working on the mechanism and I'll show you most interesting moments. See you in a moment. Okay, as you may see, nothing new. We already seen this multiple times. That's a cam gear belt. That's why it doesn't work. It's already stretched and it was not holding well. Alright. This part hasn't been disassembled before. So if the belt was replaced, it was on the capstan belt. Alright, so I'm moving forward. Now I will remove reels, then replace idler tire, lubricate everything, clean, lubricate and assemble everything back. You may refer to my other videos. I already was working and filming multiple videos, and specifically on the ZX-9 and on the Dragon, so they are quite similar. And the only difference that the ZX-9 has one motor and one FG coil, alright? When Dragon has two motors and two FG coils. Technically they're very close. Alright, so let me continue working. See you in a moment. Okay guys, I just installed the new idler tire. So it will work for another 10 years at least. That's the old one. It's shiny, it's plastified and cracking. Alright, so it will go to trash. Now I will lubricate both these mechanisms because we have a brass bearing here and we have another brass bearing there. So it will easily move into the necessary direction, and then we'll start assembling. I will have to clean up and lubricate and replace belts, but we're moving on. See you in a moment. And here guys, I'm continuing. I'm assembled the part from the back, installed new belts, and now I'm disassembling the head block to clean up this old lubricant, add new one, so our azimuth wire will start work smoothly. So moving on, should be done soon. See you. Alright, I clean it, lubricate it and assemble it. Now you may see that azimuth mechanism works easily and spring can pull it back, and that's how it works here. So you may see the record head is adjusting its position. Good. Alright, let me continue assembling. See you in a moment. Okay guys, and here I completed assembly of tape transport, attaches the flexi wire, and now I can move the head with my hand. You see it moves. Alright, now it's time to install it back into the body, and let's see how everything will perform. See you soon. Actually, before the final assembly, I decided to remove the boards, deoxidize the switches, alright, because it would not be possible to access them after I put the boards back, alright. So, see you soon. Okay, everyone, I just completed assembly of the front panel, connected everything. Cleaned the tape pass, demagnetized the heads, and now it's time to check how everything works. Quiet and quick. And we have playback levels. Woohoo. Alright. That's a good sign. So I deoxidized these 3 ports, all these 5 switches. It's pretty hard to get to these ports because they install it on the boards. So let me see. Oh, I forget connect azimuth wire. Let me connect azimuth wire and let's see if it can calibrate now. Okay, everyone, I'm attached azimuth wire and put the knobs. So now let's see, it's 120 microseconds. EX type. Let's see. Let's see levels. I don't see 400 gears levels. Source. Yeah, there is no on the source as well. So generator doesn't work. Bias. Source. Okay. 15 kilogears works, but 400 gears doesn't work. So I need to check what's wrong with the generator. Alright, see you soon. Alright everyone, here I'm back. I was researching what's happening and why we don't have 400 gears. And here we go. On the pin 2 of the op-amp, which should give 400 gears, it just permanently runs 61 gears. Whenever I do turn on, turn off, use 15 kilogears, whenever, and this is the op-amp. And on pin number 1, it's quite dead, right? So the problem with op-amp, I suppose, because like there is nothing more connected to the pin number 2, as you may see. And it gives like full amplitude, 16 volts, peak to peak. Alright, I checked power supply, it's quiet, no any pulses, everything around is fine. So looks like I have to desolder and replace this microchip. See you soon. Alright guys, it still don't help, so I replaced this op-amp. It didn't help, I replaced this 100 picofarad. It didn't help, replaced this 0.1, didn't help. Replaced this pot, it didn't help. At this moment, like, I don't know, this generator don't want to start. And I just not sure what's prevented it from start oscillation. If I touch the legs of this microchip, it starts, but not full on. Let me see. So that's 15 kilogears, it works right away. 400 gears don't work. If I touch it, you see, it oscillates and it dies right away. It's been two hours already and still no success. Need ideas. Okay, if I introduce resistor between inverting input and the ground, right, at this time, like, it will increase the amplification of this op-amp. Then it immediately starts to jump into the square form generation, right, on the full amplitude between plus 12 and minus 12. It gives me like 22 volts amplitude. So technically op-amp works, but something with the circuits which don't want to work normal way with required gain selected by 390 kilo ohm. I'm quite lost what else I can do here. So you may see, oh, I turn it off. Let me turn it on. And that's the port I introduced it. That's the full scale amplitude. And frequency is suspectfully low. We have 50 milliseconds per square, and it goes really slow, below 10 Hz, right? So that should not be happening, even like with good amplification and having the square wave, it still should go like to 400 Hz approximately, and it's don't. All right. So still thinking, still working on ideas. See you soon. All right. I don't understand something. So that's power supply, that's crank boards, where I assembled the similar schematic as in Nakamichi, and this generates, but frequency, see, period is 1.76 second, so it's below 1 gigahertz with these parameters. And I tried to start it, like, and nothing really helps. Trying to do pulses, really. No luck. You see, this pulses from my hand, right? It's higher frequencies, but that's it. I need to understand how to properly set frequency and why it doesn't work. See you soon. All right. 15 kilohertz, 400 hertz, but level is a little bit too low. I need to check what's wrong. And the culprit, so this mostly works like a low pass filter, and the frequency generator is this part of the IEC, right? And this transistor switch between 400 Hz and 15 kHz. So when this capacitor is disconnected, works this capacitor, 360 picofarad, and we have 15 kHz generator. And when like transistor connects this bigger capacitor, frequency drops to 400 Hz. That's how it works. And here the signal goes through this latch here and initiate 400 Hz square pulse here, which gets filtered with this integrating amplifier. So it's not generator. I'm sorry. So this just integrating amplifier, and it makes sine wave feeding into this filter. And here we get square waves, which filter is like on 15 kHz by this capacitor, this pot, and this filter, and goes to the output. That's how it works. Right? Now when I know it, so here is the culprit. These two orange capacitors which failed and didn't work as needed. Okay? I replaced them. Alright. Good. Finally I was able to solve it. It took time, like it's already almost 4 hours since I'm working on the generator. See you soon, bye. And here guys, I want to show you confirmation. So right now we have 15 kilohertz, and it's you see 15 here as the same pin, right? Measuring, and we have high frequency. Now I'm clicking the 400 Hz, and you see same generator, same pin. It just switched it to lower frequency. So I didn't touch other pins, and that's the integrating amplifier. Let's give smaller amplitude, but it's, you see, makes sinusoidal signal. So that's on the pin 2, pin 3, and almost no have, very small, and pin 1 on the output. Yeah. We have low frequency amplitude signal, right, which is integrated. Let me add zoom a little bit so we would be able to see it better. You see, so it's integrated. All right, so that's what I did show you. So on this pin 7, right, I show you two signals with different frequencies, with this transistor on and off, and then I show you output on pin 1, which after this integrating amplifier, and it gives sinusoidal signal. All right, see you.